Alright, this is the notes for section 7.7 and 7.8, rational exponents, both positive and negative. We're going to do these two sections together because they go very well together, and I think that sometimes it's just easier to see this whole thing if we look at the both positive and negative rational exponents together. If you haven't done so already, make sure that you read 7.7 and 7.8 before continuing on with this video. Okay, so the first thing I want to do is look at the rational exponent theorem. And what the rational exponent theorem says is that if we have a non-negative real number x, that's key, it's got to be non-negative. If it's negative, this isn't going to apply. Okay, so here's my value x right here. Okay, and positive integers m and n. So when I look at the values of the m and n, they have to be positive integers. Well, then I can say x to the m over n is the same as x to the 1 over n raised to the m power. Okay, so the mth power of the nth root of x. In other words, when I look at a rational exponent like I have here, okay, that rational exponent, m over n, can be broken down into two parts. The first part being the power, and the second part being the root. Okay? And it doesn't matter the order in which we take the power or that we take the root, but when I have a number that's being raised to a rational power, some number over another number, the top number represents the power and the bottom number represents the root. So I'm going to take that number, I'm going to raise it to the mth power, and I'm going to take the nth root of it. So in 7.8 we started looking at negative exponents. Well, if you think about it, when I take a number and raise it to the negative first power, something like this, if I have 5 to the negative first power, that means 1 over 5. So all the negative means is the reciprocal of. Okay? So what that means is that x to the m over n and x to the negative m over n, those are just reciprocals of each other. Okay? And if they're reciprocals of each other, that means if I multiply those two things together, they will be equal to 1. Okay? So really what it does is if we look at the power of any number that's a positive number, okay, as long as x is positive, we can do the following. It doesn't matter the order in which we do it, but we can take the reciprocal of the number, we can take the nth root of the number, and we can raise it to the m power. And it doesn't matter, we can do that in any order. So I could raise it to the m power, take the n root, and then take the reciprocal. I could take the n root, raise it to the m power, and then take the reciprocal. The order doesn't matter. But what we need to know is that the negative sign is the reciprocal. M is the power. And n is the root. Okay? So those three, so as you look at any rational exponent, you want to think about those three things. Negative is the reciprocal, m is the power, n is the root. So let's take a look at this first example here. It says that x is greater than or equal to 0, and we want to simplify this. Well, if x is greater than or equal to 0, we know that we can use rational exponents. So I'm going to start by taking this rational exponent of 2/3 and distributing it to everything inside the parentheses. So I have 27 raised to the 2/3 power, and I have x raised to the 6th times 2/3, which would be 12/3. Okay? So now x to the 12/3, I know that's going to be x to the 4th if I simplify that rational number, 12 over 3, which is just 4. Now I'm going to work on this 27 to the 2/3. Well, that's the same as saying 27 raised to the 1/3 power raised to the 2nd power. So now what I'm going to do is I'm going to take this means the third root. So 27 to the 1/3 power. Well, what number can I multiply by itself 3 times to get 27? That would be 3. So that's the same as saying 3 squared. Okay, so I've taken care of this stuff. So now I'm left with this stuff right here. 3 squared is 9. Therefore, that is equal to 9x to the 4th. Let's take a look at example 2 then. It says solve x raised to the 5/4 is equal to 6.8. Okay, so we have to, first of all, we have to assume that x is greater than or equal to 0. So if I'm going to do that, I got to get x by itself. Well, I've got to think about what do I have to raise this to such that I'm going to have just x, and that would be to the 4/5 power. So if I'm going to raise that to the 4/5 power, I have to raise this to the 4/5 power as well. So x to the 5/4 raised to the 4/5, that is the same as x to the first power, or just x. And now I'm left with 6.8 raised to the 4/5 power. And that's where I would go to my calculator to go ahead and do that. Now I could take the 5th root of it and then raise it to the 4th power. But I don't know what the 5th root of 6.8 is, or what that would be raised to the 4th power, so that's why I would go to my calculator at this time. So on my calculator, I'm going to enter 6.8 raised to the 4/5 power, hit enter, and it will give me my answer, which is about 4.63 if I round it to the nearest hundredths. So I'm going to come over here and put in that value, 4.63. And I should change this to approximately 4.63. And that would be my answer. Approximately 4.63. Alright, number 3 says the price of a Volkswagen Beetle in 1959 was about $1,700. In 2008, the price of the same model was about $17,000. What was the average annual percentage increase in price over these years? So I'm going to start with my interest formula, okay, because it's very similar to an interest problem, where I want to solve for R. Okay, I know the other information and I can plug it in. The amount it's worth now is $17,000. The amount it started at, or its principal, was $1,700. And then I don't know what R is, and then I'm going to raise it to T. Well, that's 49 years, so I'm going to put 49 as my exponent. Okay, so now my goal is to solve for R. So I'm going to begin by dividing by 1,700 on both sides. Okay. If I do that, 17,000 divided by 1,700 is 10. So I have 1 plus R raised to the 49th power is equal to 10. Well, to figure out what that is, I can raise this to the 149th, and I can do the same over here. Okay. Now if I do that and solve for R, okay, I'm going to get 1.0481, and then I have to subtract is equal to 1 plus R, and then if I subtract 1 from both sides, R is equal to 0.0481, or 4.81%. That would represent the annual percentage increase. So let's take a look at number 4 here. It says use the formula that R is equal to 241 W raised to the negative 1/4 power. It's the same formula they gave for heartbeats in the beginning of the lesson for 7-8. And it says where W is the weight in kilograms to estimate a person's resting heart rate in beats per minute if the person weighs 240 pounds. Well, the first thing I want to do is, my formula is not in terms of pounds. My formula, W, is in terms of kilograms. So the first thing I'm going to do is I'm going to convert that, which is like taking that number times 1 divided by 2.2, just like we did in the lesson. If I do that, I find that it's 109 kilograms. Okay, so that's the value I'm going to plug in for W. So I have 241 times 109 raised to the negative 1/4 power. Okay. So when I go to put that in my calculator, I get this, 241 times 109 raised to the negative 1/4 power, which gives me about 74.58. So if I round it to the nearest beat per second, that would give me, beat per minute, that would give me 75 beats per minute. Okay, let's take a look at number 5 here then. It says, suppose Gary has $75,000 of the $200,000 he hopes to have in a retirement account in 8.5 years. What interest rate does Gary need to meet his goal? Well, we're going to use the formula that was given to us in the lesson there, and that was that S is equal to G times 1 plus R raised to the negative T power. Okay. Now what I'm going to do is I want to solve for R, so I'm going to plug in what I know. Well, my savings is at 75,000. My goal is 200,000, and the time, instead of 8.5, I want to write that as a rational number. So I'm going to write that as 17 halves. Okay. So if I plug those values in, negative T, so it's going to be negative 17 halves. So I have this. So to solve this, I have to take and raise each of these to the inverse of that. So that would be to the negative 2 over 17. So 1 plus R would be equal to 75,000 divided by 200,000. So if I go to my calculator, 75,000 divided by 200,000 is 3/8. So I have 3/8 raised to the new negative 2/17, which is 1.12% roughly. So that means that 1 plus R is equal to 1.122%, or 0.122 for the rate, which is about 12.2%.